today I am doing 1-16. Here we go. Took me a minute to get everything set up. Anyway, 1-16, inverse trig functions. So inverse trig functions, inverse and reciprocal get confused sometimes, but inverse undoes or reverses something, okay? The inverse, when we want to solve for 3x equals 9, the inverse of 3 times x is division, so you get x equals 3. So undo or working backwards. So sine function, we usually write it like this. The angle measure is the input, the trig ratio is the output. And you know when we have the point on the circle, your sine is your y value, okay? So you go to the circle, you go to pi over 3, you look at your y value, and that's your answer, square root of 3 over 2. Now what an inverse function is we're given the square root of 3 over 2, and we want the angle out, okay? So this little symbol right here means the inverse sine function. It's a -1, and again, sometimes it gets confused with reciprocal, but with trig, that means that we're finding what value, what radian value would give us square root of 3 over 2, and that is pi over 3, whose angle. So let's do these. Now these first two are real close to each other, so I'm just going to draw a line like that to show you the difference of the two, and I can zoom in a little bit. So have your circle ready. So pi over 4. So where is pi over 4? Is right here. Our sine is square root of 2 over 2. Now this one says 1 over square root of 2, and let me show you how they got that. So square root of 2 over 2, we have 1 over square root of 2. We usually don't like the radical in the denominator, so you multiply by square root of 2 over 2, and that equals the same thing. So 1 over square root of 2 and square root of 2 over 2 are the same thing. So what you would do is, if you didn't know, because we just did it, you go to square root of 2 over 2 for sine, and your angle is pi over 4. I'm just going to do, we already know how to do the angles, right? You find that angle and you find x or y over x. So I'm going to work backwards with these. Sine of 1/2. So where is the y equal to 1/2? Well, there's one right there. And that is the only one. No, there's one right here. So there's two values it could be, pi over 6 or 5 pi over 6. Usually I go to the first one that you are closest to 0 that you run into. So pi over 6. Pi over 2. Where is sine equal to 1? Well, right there. That's the first one we run into. That's the only one, because over here is -1. So pi over 2 is the only answer for that one. 0, cosine. Cosine, not cosine of 0, where what angle is the cosine equal to 0? So your x value is 0, it's this one and this one. And usually I say the first one you run into, so pi over 2. Here is 1. So where's the first one that your x is 1 is right there, and that's the only one. So it is 0. Tangent is a little tricky. I'm going to cover this one. -1. Why? Because the tangent on the circle is y over x. So to be negative, you know this is plus plus. This one's negative plus, this quadrant is negative negative, and this quadrant is positive negative. Oops, I put a 1. But in order to get a -1, it would have to be in quadrant 2 or quadrant 4. So here the tangent is 1. Here the tangent is -1. So 3 pi over 4 or 7 pi over 4. Or we will learn that tangent, we look at this half and this half, and this half is a negative. It's not all the way around and these positive values. So this is positive pi over 2 and this is negative pi over 2. And with that case, that's where we get negative pi over 4 for this angle. Okay, move that mouse out of the way. Page 2. So 1 over the square root of 2. Now remember, that is square root of 2 over 2. We're looking for the cosine. There is 2 places. It is either here or here. So I say to hit the first one that we run into after 0, and it's pi over 4. Sine of 0. Here or here, first one we run into is 0. 1 over the square root of 3. So remember, tangent, again, is y over x. And when we have the same denominator, it is your y numerator over your x numerator. So which one has a y numerator of 1 and an x numerator of square root of 3? So y numerator of 1, x numerator of square root of 3. So that is pi over 6. Cosine of 1/2. You go to the x value of 1/2, and the first one we hit after 0 is pi over 3. Okay, have you wondered if that's pi over 3, can we also say that we keep on going around the circle, and there's lots of them that could be 1/2. That one, around the circle. Well, 7 pi over 3. Oh, that's over 2 pi. Yeah, you could keep on adding 2 pi and say this one, add 2 pi. So this is 6 pi over 3, 7 pi over 3, on and on and on. No. Why? Because of definitions. So similar to PEMDAS, since there are multiple ways you could find the angle, we use definitions to find the angle. So why do I say PEMDAS? Is because PEMDAS is the order of operations. If we didn't have this order of operations, we'd all do the same problems and get different answers. Same with finding the angles. Since there's so many multiples of them, we could find the angles, and we're going to get into that next. Why? So there's many angles, but we have defined only one angle measure. For cosine, it is pi over 3. And I'll show you the different functions on why that one is pi over 3. Okay, so looking at this, specifically they're defined as this. Sine is from pi over 2 to negative pi over 2. So it's this right half of the circle. Remember, this is 0 up there, 0, negative. Cosine is from 0 to pi, so the values that fall in between there. And tangent, remember, even though tangent is y over x, it's similar to sine. So pi over 2, negative pi over 2. So 0, positive, and then those are negative angles, okay? So domain -1 to 1, which are these values, we're looking at that part of the circle for these specific things. This again is cosine, this is tangent, and sine are similar. Okay, so let's do this. I'm going to keep those circles up for just these two because I can. Tangent of 0. So we want to find what angle gives us a tangent of 0. Tangent is y over x, so our y has to be 0. And the first place that we have y is 0 is at 0. And that falls in that half of the circle. Cosine of 0. Now, cosine of 0 isn't till up here and down here because of x values, but we look at just from 0 to pi, so it's pi over 2 for cosine of 0. What angle will give us a 0? The next two are sine of negative 3 pi over 2. So sine is this half. So looking at this half of the circle, where is the y, negative 3 pi over 2? Well, it's here, but this is considered this part of the circle. So we want to do the negative. 5 pi over 3, the negative value is pi over 3. Okay, so this is your positive, your negative is kind of like the reflection of that one. So it is negative pi over 3. And then cosine of negative square root of 3 over 2. Cosine again is this top half. So negative square root of 3 over 2 for the x. The first one we run into is right here, which is within our boundary from 0 to pi. So it's 5 pi. Oh, no. It's, 5 pi over 6. Yes. Even though it's a negative value, it's because our negative is right there. Okay. Cosine of negative 1/2. So first place we hit x of negative 1/2 is right here, 2 pi over 3. I'm going to go to here, tangent of 1, our y value of 1. No, not our y value of 1. Tangent of 1 is y divided by x, so it's a positive. Remember, tangent is this half of the circle. So when we divide and get 1 is this value right here. So it's pi over 4. Sine of negative 1. Sine of negative 1 is down here. And that is within the half of the circle for sine. But pi over 2, this is negative pi over 2. And then tangent of negative 1. When we divide these, we get 1, negative 1, negative 1, 1. So this one is within 0 to pi no. Tangent is over on this side. I'm sorry, I was doing cosine. But cosine you don't divide. Tangent's over here. This one is within there, but we use the negative value because it's from pi over 2 to negative pi over 2. So this is negative pi over 4. Okay. All right. So at least 4 solutions in the circle where it's negative 1/2. This is not in our specific place for sine. We could do negative 1/2 for y. There's one right there. There's one right there. We could also do this negative pi over 6. Negative 5 pi over 6. And then 7 pi over 6. And 11 pi over 6. Those are 4. But the one that's unique for sine is negative 1/2 y is this one. But we don't say 11 pi over 6 because it needs to be less than pi over 2. And so it's negative pi over 6. So we've been calling them the inverse. You may also see these called the arcsine, arccosine, and arctangent. They mean the same thing. So either inverse or arccosine. So these are the only things, so find the only angles. So we've got to remember where we're looking for. Tangent, so this is the same thing. So tangent is y over x. That's a 1. So which one has a y numerator? Tangent, remember, is in this half. square root of 3, and the x numerator 1. It is pi over 3. Arctan of negative, so a negative square root of 3 over 1. So negative square root of 3 over 1 is right here, but it reflects to be a negative pi over 3. This is your answer. I'm just showing you how to find the value. So sine of 1/2, again, sine's here. It's your y value of 1/2, pi over 6. I'm just going to keep this up and go here on the left side. Cosine of 1 is right here, which is between 0 and pi, which is our cosine, pi over 2. Arctan, we have negative 1 over square root of 3. Remember your y numerator, your x numerator. We need a negative. Negative 1 over square root of 3. Tan is in this. So it's this one, which is positive, but we want a negative pi over 6. Now for the other side, arcsine of 1 over square root of 2. Remember 1 over square root of 2. If we rationalize the denominator, we get square root of 2 over 2. So where is our y equal to negative that? It is right here. Again, we want negative pi over 4, not 7 pi over 4. Cosine of negative 1 is right here, which is within our cosine half circle. And cosine of 1 over square root of 2, remember that's negative square root of 2 over 2. So our x value for that is right here, which is in less than pi for that circle. Okay, those are those values there of those angles. And I think that is it for lesson 16. I said 1 of 4 pages. I guess I did the 4 pages. Okay, let me know if you have any questions. Thanks.